Okay, so welcome back, and now what we're going to do is start talking about multiplying series. And so we're going to start off with a theorem. And so the theorem is the basis of what we're going to use to multiply series together or find representations by using products of other representations. Okay, and so you'll see in the examples to follow. There is no proof for this. The proof is beyond the scope of this course. It's usually saved for more advanced classes, but we're still going to use this theorem. Okay, so know and make sure you know how to apply this theorem. Okay, so first of all, it says suppose that we have these two power series. Okay, this one and this one. Okay, where we have c sub n times x to the nth power here, and we have d sub n times x to the nth power here. And let's assume that they converge to these functions, f and g respectively, on a common interval. Again, remember, so on a common interval I. Also, it says let us define e sub n. So we're going to define e sub n as this partial sum. Okay, so it's a sum of the products of the corresponding coefficients of these two series. But in this case, c is going up in n, d is going down in n. So this is c0 times d sub n. This is c1 times d sub n minus 1, and so on. And it goes all the way down. And so we can define this as a partial sum given by this, denoted by this expression. So k equals 0 to n, this sum of c sub k times d sub n minus k. Okay, so it's hard to see that, but that's why I'm saying it. Okay, now defining e sub n this way, then by this theorem, we can define the product of the two series is equal to this. Okay, so if you take these two series, multiply them together, they will equal this, which is a sum from n equals 0 to infinity of e sub n times x to the nth power. And also this series of e sub n times x to the nth power converges to the product of the two functions f of x and g of x on the interval I, that common interval. Now, the series e sub n times x to the n, this power series is known as the Cauchy product of the two series. Okay, and that's it. So we're going to do some examples of how we would use this theorem to help us find a representation of more complex looking functions by using this Cauchy product. Have a good day.